Okay, we're continuing on to a next example, example 7. So solve the triangle. Can we use the law of sines? Well, notice that we have an angle here, but we don't have a value of the opposite side, so we are stuck. Can't use the law of sines, but we can use the law of cosines. Law of cosines. Okay, now let me redraw the triangle. Here, let me just put it right here. The redrawing of the triangle helps orient yourself to the sides because it forces you to think about what you're writing. Not everybody has to do that. I explained that before. But anyway, we're going to call this A, and then this is B. So that tells you right away our key. You know, I mentioned the key is making sure that you could keep up with solving a triangle. All right, angle C was 30 degrees. We got that. Little a is 10. Little b is 12. And there you go. We're sort of stuck. So remember, if you want to shortcut, the law of cosines works when you have when you have two sides and the included angle. Okay. So let's let's take care of this. So it's the p squared equals a squared plus b squared minus twice their product cosine of the included angle. All right, the side we want is x squared is equal to what? 10 squared plus 12 squared minus twice their product, that's 120. We could write it like that if we want to. Then cosine of the angle 30. It's really just a calculator problem. All right, so so when you multiply that all out, you're going to get a value. Now, I did that on my calculator. I know you know how to use your calculator. That's 36.15, keeps on going. Now remember, that is in this key of your calculator. Okay, answer. It retains all of those decimal values. So to find x, you just take the square root of your answer. That goes back to the calculator videos I gave you at the beginning. So here, x is equal to 6.01. So C is equal to 6.01. Oh man, if I just knew angle B and angle A, or how about just one of them? Well, we can if we use what law? Good question. Now we have a pair. We have a side and we have an angle. So we could use the law of sines. I don't know, let's just say, I'm going to pick the smaller one, A. Okay, so 10 over the sine of A. Then when I go through that procedure, I get 56.3 degrees. So A equals 56.3 degrees. This goes here. Should really do that in the other color, okay? Now we know that these two guys give us 86.3. So 80, that's 106, that's 93, 94, 93, 93.7, okay? 93.7 degrees. Okay, right here. All right, now again, you could check it. Look at the smallest side. Is it across from the smallest angle? Look at the biggest side. Is it across from the biggest angle? No, somehow we messed up. Okay, we messed up because I wrote the answers in wrong. So that's another reason why we should be checking our work. So let me fix that. Okay, so remember, this was 56.3. I hope you caught it when I was doing that. I didn't mean to do that on purpose. And then 93.7 degrees, okay? I hate making mistakes, but I do make them. And we go on. That's all you can do. All right. Okay, now look at this next problem. It is a little interesting. We're going to call this, we'll call this example 8. Now here's a triangle, but notice there are absolutely no angles in there. There are no angles in the triangle. How about we call this example 8? Well, how are we going to do that? We certainly don't have a pair, okay? Can't use the law of sines. Can we use the law of cosines? Can we use the law of cosines? This is where it helps to know how the law of cosines works. First of all, do we have sides? Yes, we do. Now, in this case, we're trying to find angle A. This is what example 8 is asking, okay? We could redraw the triangle. Some people like to do that. It's going to look very similar to the one above. Here's angle A, and this is 20, this is 25, and this is 18. Now, probably a good piece of advice is this possible to have a triangle? Is 25 less than the sum of the other two parts? Yes, it is, okay? So that kind of helps you out. All right, well, let's find angle A. Here is the opposite side. 20 squared is equal to, notice the sides that make up angle A. 25 squared plus 18 squared minus twice their product. What's their product? 20 times 18. Well, double 18 is 36. No, that's messed up. 25 times 18. I'll just write it that way. Cosine of, you could say A or you could say P. I'm just going to say A to make it match our little diagram there. Now, if you're doing this for the first time, how do you do this? You're going to take your calculator. You're going to do 20 squared minus the 25 squared minus the 18 squared, right? Wouldn't that just move these guys over to the other side? But then you have this part left. This piece, and then the cosine. So we're going to have to divide out this. So what I'm going to do is I'm going to hit divide on my calculator, but I'll put this in parentheses or hit equal. Divide by a negative 2 times 25 times 18. Now you do that any way you want to do that. When I do that, I get cosine of A is equal to 0.61. All right, now hold the phone here. Cosine's positive here and here. I don't think we're going to have to worry. Okay, you're not going to have an angle greater than 180, right, in the triangle. All right, so inverse cosine of 0.61 is going to give you 52.4 degrees. Okay, that's all we had to find with this particular example. All right, what are we looking at here on example 9? Oh man, that's a great question, okay? Let's see. This is your cell phone, and then you have two towers that are 6,000 miles apart. The question is, could you find how far east or how far west are you from a particular location? How far north, how far south? Well, good question. Good question. Okay, there are no angles in this triangle, but can I use the law of cosine to find an angle like theta? Now notice in the bottom triangle that theta, we found out using law of cosines, was 23.3 degrees. And you know from that triangle you could solve for the two other parts of the triangle, and you could find out from this tower down at the bottom, right? Okay, how far east and how far north you are. Now, having been around for a little bit longer period of time, I know of people that just in the state of Georgia, I remember hearing about a gentleman that fell off of a telephone pole somewhere away in the boonies, and he had a cell phone with him, and they were able to find his location. Now, the idea of GPS and TomToms, and you're using some type of app, it's just phenomenal the amount of technology that we are enmeshed with in our culture. A lot of times it's kind of hard for you to figure it out because you're so blinded by the immense amount of technology, and I understand that. But know this, behind technology is some science, behind the science is some math, some type of order. And you could learn about it, and Trig is a good place to get your mind around some of that math. All right, that was a little bit explanation on example 8. I'm sorry, that wasn't example 8, that was example 9. Now, let's look at example 10 and do a really good job on this problem. We want to know how high that hill is. If you've ever looked on a map, you realize that, heights of things are really important. Let's see if we could figure this out. First of all, notice we have a triangle, kind of a strange looking triangle here. Now, if this angle here is 24 degrees, isn't that angle going to be 54? That makes sense? No, if this is 24, that's 156. Okay? And we know this angle is 22 degrees. And we know that this length right here is 200. Question, can I find this length that I'm writing in bold here? Because if I could find that length, I could use that length and what I know about right triangles, since I know this angle is 24 degrees, to find h. And if I just know that x, remember that x is this x. Well, hey, we can do that. Because we know that 156 and 22 is 178, and 2 degrees right here at the top will round us out to 2 degrees way up here at the top, okay? Will round us out to 180. Let's do the law of sines. Okay, 200 over the sine of 2 degrees is equal to what? We're trying to find x, so it's going to be x over the sine of 22. Okay, we've been through the procedure on figuring that out, and we know that x is equal to 2146.77. Now, folks, that's pretty good amount of feet. Now, but in this triangle, if I took that x out and put 2146.77, can I solve it for the height of the mountain? The answer is yes. Simple sine. Sine of the angle. I'm having trouble with my pad here, okay? 24 degrees is equal to the opposite over 2146.77. I don't know how that Sal Khan does it here. All right, remember we've done this about 30 times. So h is equal to this number times the sine of 24, which gives you 873.17 feet. Okay, that's how I would write the answer. Now on your test it may be a different rounding, but there you go. And again, this was example 10. Whoops. Okay, like I said, this particular problem was the last example, really for our lessons, right? Example 10, okay, on 9.2. Folks, that rounds out all of the examples in lesson 9. Now, folks, I know that you struggled a little bit with Unit 8, and I tried to give you some advice and warned you ahead of time. I want to thank those people for working through that unit. In this unit, it's more of application and really kind of some of the basic problems. We could expand upon these ideas and do so much more. Folks, and that's what mathematics is. It's tools to help you realize that you could do more. You could apply more of your knowledge. And some of you may not be designing the next, three-sided figure, but you will be using GPS and you will be listening to music, which are both trig-related concepts. I certainly wish you the best as you finish off this good unit.